All right, my 3 AP Calc kiddos, I'm actually kind of excited that I get to teach this for you because I really love teaching it. Unfortunately, there's no way we have enough time to cover it all and to keep you guys from being so stressed out in regular classes. So I don't get to do it, but I get to do it with you guys, so I'm pretty happy about that. Okay, so these are trig proofs. Trig proofs. All right, and it says to be able to do trig proofs, wow, we had better know our identities, right? So our identities, I'm going to have them out sitting here, right here, right? All of our trig identities, because we're definitely going to be using them. Okay, so some examples, and something that particularly Miss Ardito and Mr. Bonner like is they want you to pick one side and work with it until it's the same as the other side. Now, I personally don't always do it that way. Sometimes I do and sometimes I don't. So it's not like a requirement. It's not a rule. It's just the way they like to do it. I personally sometimes don't do it that way, but okay. So we're going to do some examples. So let's go ahead and start with example number 1. We're trying to prove that tangent theta times cosecant theta times cosine theta equals 1. And so to do that, right, I don't even know if this is going to be enough room. I'm going to have to write so super tiny. I'm going to come over here and I'm going to look at my ratios. Okay, so I've got some, generally, like I said before, I generally don't touch like sines and cosines, but tangents and cosecants and cotangents and all that I do. So I'm going to go over here and I'm going to say, okay, I have a ratio for tangent, which is sine x over cosine x. Now, the cool thing about proofs is that when you get them right the first time, they're amazing. But the other cool thing is that when you get them wrong, you're still learning so much. And I shouldn't say wrong. You might go down a pathway and it ends up that wasn't the correct path to pick. And that's okay. So if you see that happening in my notes, know that that's really what happens when you're doing proofs. A lot of times you start to do a proof and you realize this isn't getting me the answer I need. I'm getting stuck. I'm going to take a different approach, and that's absolutely fine. All right, so I'm going to rewrite tangent as sine over cosine. So sine theta over cosine theta times cosecant. I'm going back to my chart. Cosecant is 1 over sine. So cosecant is 1 over sine, and then times cosine, which is cosine over 1. And that's supposed to equal 1. So what I notice is that these will reduce, and I get that 1 equals 1. Check, done. Wasn't that super simple? That was a beautiful, beautiful trig proof. All right, let's do another one. They can get harder than that, and I bet you they are. So we're going to prove that secant theta plus 1 times secant theta minus 1 is equal to tangent squared theta. I'm going to choose to work on this side and leave this side alone. So what I'm going to do is I'm going to go ahead and, now I might be making the wrong decision. Again, I don't know for certain, but I'm going to go ahead and multiply this together and see what happens. So if I multiply here, I get secant squared theta. If I multiply here, I get minus secant theta. If I multiply here, I get plus secant theta. And if I multiply here, I get minus 1. And that equals tangent squared theta. So then what I notice is that these will reduce. I have positive and negative secant theta. So that gives me secant squared theta minus 1 equals tangent squared theta. I just want you to know I have not done these problems ever before, so I might be going down the wrong path, but this is my method. This is what I would think to do. All right, then I'm going to go back and look and see whenever I have like secant squareds or anything squareds and a minus 1 or a plus 1, it always makes me think of this sine squared x plus cosine squared x equals 1. And so remember we derived a bunch of different ideas, and one of them was right here. And what I see is a 1, a secant squared, and a tangent squared. So what if I were to take this equation right here, right, and say solve for tangent? So if I were to do that, I could move tangent over. So I get tangent squared x plus 1 equals secant squared x. And then I would subtract 1 from each side. And I get tangent squared x is equal to secant squared x minus 1. And so what that tells me is that secant squared x, or sorry, secant squared theta minus 1 is the same thing as tangent squared theta. So this is tangent squared theta equals tangent squared theta. Again, using this identity. So it is absolutely fine to use an identity, which this is an identity. All right, next, we're going to prove that 1 minus cosine squared y over sine y is equal to sine y. Oh my, I just spilled my coffee. Hold on, guys, just a second. Okay. Sorry about that. Okay, next. Again, this time I'm going to work on the left-hand side again. I think I'm going to leave sine y by itself. And I have 1 minus cosine squared y. Again, directly using an identity. This looks like an identity to me. So I'm going to come over here and see if I have an identity that talks about 1 minus cosine squared y. So 1 minus cosine squared is the same thing as sine squared. So I'm going to use this identity right here and rewrite the numerator. So this is going to be sine squared y over sine y is equal to sine y. And then what happens is sine squared y is sine y times sine y over sine y equals sine y. And then these two, right, we can reduce out a factor. And so I get sine y is equal to sine y. All right, this time I think I'm going to leave this side alone because it's kind of already just sine by itself, sine squared. So I'm going to go ahead and work with this side. So I have sine, oh, let me change color, sorry. Sine squared y, or sine squared theta, excuse me, is equal to 1 minus, now I'm going to rewrite this 1 over, whenever I have a fraction, I tend to try to simplify it. So 1 over secant squared, well, secant is the same as cosine, right? 1 over secant, I should say, is the same as cosine. So this can be rewritten as cosine squared. So this is cosine squared theta. All right, and then 1 minus cosine squared theta, 1 minus cosine squared is sine squared. So I get sine squared theta is equal to sine squared theta. Again, replacing this with its identity.